Over here we got our Cisco IP phone. In most corporate environments, the IP phone itself on the bottom has two ports on it. One says 10/100 switch and the other one says 10/100 PC. And what you'll see is the 10/100 switch port goes from the back of the phone into a jack at your cubicle or somewhere around your desk. And that's what allows the phone to connect to the network and have connectivity, right? And currently, you notice this phone does not have any power cable plugged into it. It's getting power over the network cable, and that's referred to as power over Ethernet. Now, if you wanted to connect your laptop to the network also, most companies don't want to have two network connections, one for your phone, one for your laptop. So what you'll do is you will connect the Ethernet port on the laptop like so, and then you'll connect the other end of that cable to the port on the phone that's labeled 10/100 PC. So I'm going to go ahead and plug that in. And then on my computer, now I'm connected using my wired Ethernet, but here I'm also connected through wireless. So what I'm going to do is I'm going to right click and do Open Network Settings. I'm going to click on Ethernet. I'm going to click Change Adapter Options. And what I'm going to do now, just to simplify things, is I'm going to go ahead and disable my wireless, just so I'm only working with my Ethernet side. And I'm going to just double check my settings. So I'm going to right click and do Properties, check my TCP IP settings, and here I had a temporary lab situation, so I'm set up for a static IP address, but really that was more for an isolated lab, and I want to go back to obtaining an IP address automatically and obtaining a DNS server automatically. So that's why I'm showing here that I'm not connected, because I had an IP address from a previous lab in here. So this is what you'll see 9 times out of 10 is the IP address is automatic and the DNS server is automatic. So I'm going to hit OK and OK. And now you'll see that it's showing that I have connectivity. But just to confirm things, I'm going to type CMD, go to a command prompt, and I'm going to type ipconfig. So here I've got an IP address of 10.196.2.144. I've got a subnet mask of 255.255.255.0 and a default gateway of 10.196.2.1. So think of this as my unique IP address. This is what puts me together on a similar network, the subnet mask. And this is my router that I'm going to connect to get to the outside world. So I'm connected right now. You can see on my IP config, it's listed under my Ethernet adapter. And I also have these other adapters, right? So I've got my Ethernet adapter 3 and 4 and my Bluetooth and all this kind of stuff, right? So it's important to understand that even though you're looking at all these different interfaces, the Bluetooth one will rarely be used. VMware has to do with virtualization, so that doesn't really matter. AnyConnect is a VPN client, so that doesn't really matter. So even though we have 6 listed, only 2 of them really matter. So I'm using my Ethernet now, so what I'm going to do is I'm going to switch. So I'm going to disconnect my Ethernet now. And once I disconnect the cable, you can see that it went red here. And now I have no connection. So I'm going to go ahead and enable my Wi-Fi. And so Wi-Fi, when I enable it by default, it may not connect. So I have to click on this interface and I depict my Wi-Fi network. So I'm going to click Transcend IT and it's already connected. So I'm now on Wi-Fi. So if I keep this IP address up here, right, this is what I had on my Ethernet adapter. if I hit up arrow and do ipconfig again, notice now I've got a completely different IP address, 10.196.4.37. And I've got the same subnet mask, so basically now my network is 10.196.4 is my actual network, and 37 is what's unique. And my default gateway to get me to the outside world is 10.196.4.1. So depending on whether you connect to Wi-Fi, or in the past if I had connected to wired, I would get, here I was on wired, I had two completely different ranges of IP addresses, because that third number was completely different, right? It was 10.196.2 versus 10.196.4. So you'll know that, users, if you're troubleshooting their issues, you'll know that if they connect to the Wi-Fi network, they're going to be on a completely different subnet than if they were on the wired network. And we've now seen what it looks like when you have a disconnected cable. So just when you connect it to a user's computer, just pay attention to what it looks like down here, because you can easily tell if you were connected to Wi-Fi or wired, and if the wired network is actually connected to the internet. So at that point, we're going to kind of look further into our IP configuration, right? So we did ipconfig, which is fine. It shows us some basic information, but ipconfig all is a much more useful command. So when we do that, notice it gave us a ton of information. The only confusing part is you have to kind of filter out all the stuff that doesn't matter. So all the VMware stuff, right? You can completely ignore that. The Ethernet adapter is currently disconnected, so you can ignore that. So really, the only thing that actually matters is the Wi-Fi adapter, because that's the only one I'm actually using right now, which is right here. So this one shows me my IP address, subnet mask, default gateway, but now it shows me all this other information. So it shows me what my DHCP server is, which is really important, and also my DNS servers, which is also important. So DHCP is basically the server that gives me an IP address. So when I first connected to the network, as you recall, my IP address was set to obtain automatically, right? So I went into here, change adapter options. When I click on this set of settings for TCP/IP, it doesn't have an IP address, right? So I'm just literally asking the network for an IP address. So the act of asking the network for an IP address is handled by the DHCP server. So in this case, the DHCP server gave me an IP address that was this, 10.196.4.37. And the DNS is basically what lets me resolve a name. So for example, there's a really useful tool called NSLookup. And NSLookup is a way that you can basically type something like google.com, and it gives me back an IP address. And I want you to do this with me here. So if you're troubleshooting, you'll type NSLookup to see if your DNS server is working, right? To make sure that you can resolve a name, because when you go to yahoo.com, the computer behind the scenes has no idea what yahoo.com is. So what it does is it asks the DNS server, which is this IP address, hey, what is yahoo.com? And it gives you back this set of IP addresses so that the computer knows what to actually connect to. So troubleshooting wise, ipconfig/all and NSLookup is extremely useful. And you can just type exit to get out of it. Now ARP is also another really useful thing to understand. So just to review, our IP address is this. So if I was to ping 8.8.8.8, that's a public IP address, that's Google's IP address, I have full internet connectivity. If I type ARP-A, which looks really confusing, but you can ignore these interfaces that are not the one that has your IP address, right? This is the only one that matters. So on this particular interface, the ARP address that we have is for your default gateway, right? So ARP is the act of basically having your computer, which has an IP address at this point, wanting to talk to something else. And notice we said that in order to talk to the rest of the world outside of my local subnet, I need to use my default gateway, right, which is right here. And the only way I can do that is by running an address resolution protocol to figure out what that particular IP address's MAC address is. So this is a MAC address right here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 characters long. And this is referred to as a hexadecimal number. So this will basically happen behind the scenes, like you never type this number in. But in order for the computer to talk to its default gateway, it did this ARP request where it basically sent a thing called a broadcast into the network saying who has this IP address and what's your MAC address. And so once that happened, then the computer was able to successfully talk to its default gateway and then was able to get out to the internet. So that's basically the IP config command, DHCP, DNS, and ARP. So another really useful command is traceroute. So trace RT and then the IP address that you're trying to connect to. So if you do trace RT, which is short for traceroute, and then the IP address, it will basically show you the entire path that you took to get there. But you are noticing that it's kind of taking a little while to have it go through because by default it tries to figure out the name that correlates with every one of these connections, right? So it is kind of nice to see, but it does take a while. So for example, I can tell that in order for me to get to Google, I had to first go to 10.196.4.1, which is my default gateway, then apparently some other IP address, which is probably a router in our internal network. Then I'm connecting to some Comcast thing, and then I'm going to Minnehaha, Roseville, I'm going to different parts of the Comcast network. So it's helpful to understand kind of the path that you take to get somewhere, because if you're troubleshooting an issue and users are complaining that things are running slow, you can run a trace route to wherever it is that they're trying to go to, and you'll see this thing called milliseconds over here. So milliseconds is literally how long it took for the computer to get to that destination and back. So 1,000 milliseconds is 1 second. So this took a fraction of a second. But if this number, I would say, is over 200 milliseconds or even 150 milliseconds, then something is generally not right. So this is like normal to be under 150. But if it goes over 150, and if this number changes wildly, that means that the latency of your connection is bad. So that's just something you can, even without knowing a lot about networking, just by simply typing traceroute and the IP address you're trying to go to, you can figure out a lot of stuff. You can also do this, traceroute-D, and then the IP address, and notice that it's going through much faster now. And the reason it's going much faster is it's not trying to resolve what names correlate to these IP addresses. Because every time it went to one of these IP addresses, it was also behind the scenes connecting to my DNS server and asking it, you know, what is this IP address? What's the name? So this one lists out all of the same information, but it's only IP addresses. Here it gives me IP addresses and names, which was actually kind of helpful because I could kind of see how it was, what cities it was going to. Here I can just see a bunch of IP addresses. So it kind of depends on what you're trying to get out of it. Those are some really, really useful commands with troubleshooting basic networking. Last thing that I want to show you guys is the concept of a virtual local area network. So when we connected to the wired network, we were on a 10.196.2 IP address, and when we connected to Wi-Fi, we connected to 10.196.4. So even though we're sitting at the same desk and we connected to our wired connection on our IP phone, and now we're connected to the access point, the wireless access point on Wi-Fi, we're on two different IP addresses. That just basically means we're on two different virtual local area networks, or virtual LANs. So just understand that if you're ever troubleshooting an issue, when you're getting two different IP address ranges, like 10.196.2 and 10.196.4, that means behind the scenes you're on two different VLANs. So just understand there's a concept called a VLAN, and that just literally means that even though you're in the same building, same floor, same desk, wireless is on one VLAN and wired is on another VLAN. That's it. We're talking about the OSI model. So there is a standard as far as what happens on a network in a theoretical sense, and there's this thing called the OSI model that's broken up into 7 different layers, and it starts with this phrase that I use: all people seem to need data packets. So if you just write that out, APSTNDP, all people seem to need data packets. That correlates back to, at the very bottom, you have the physical layer. So this has to do with what we just showed you before, which is the act of physically connecting your network cables. So either connecting to wireless or connecting to the wired network, that is the physical layer. The data link layer has to do with the VLANs, which has to do with the fact that if you connect it to wired, you're going to be on one set of IP addresses, which is on one VLAN, which is the VLAN part. Think of it as a group, and that's going to separate you from, for example, wired and wireless. So that VLAN part, the virtual local area network part, happens at layer 2. The network part has to do with IP addressing and routing, right? So just like this picture shows you, routers and switches have to do with layer 3, specifically routers, right? So this icon right here. So routing has to do with allowing one IP address on one range to talk to another IP address on a different range. And then really 4, 5, 6, and 7 are something that really more matters to people on the application side of things. So like, for example, at the application layer, you will troubleshoot things like Outlook connecting to your Exchange email server. So that would happen at layer 7. The way that that email is presented and encrypted would happen at layer 6. The embedded icons inside of your email, like different JPEGs and whatnot, that happens at layer 5. And then layer 4 has to do with email runs on a protocol called SMTP, or Simple Mail Transfer Protocol, and that uses a certain TCP port number, which is 25. So, which really, this sounds kind of obscure and random, but just keep that in the back of your mind that every single application on the network at this layer, at layer 4, uses a TCP, or Transfer Control Protocol, port number. So there's just a range of ports, and every single application has a dedicated port. So email is 25. If you try to connect to a web server, that would be TCP 80, for example. So this is just an introduction to the OSI model. You'll be also going over this with your trainer. So just take some notes and be ready to present this.